All right, that's the end of our discussion of gases and the kinetic molecular theory, etc. So now we're going to shift gears a little bit and we're going to continue and we're going to talk about solutions, okay? When we talk about solutions, a solution, again, is just, this is a review here, are just homogeneous mixtures, which means basically a solution is you've taken something, you've put it into water, and you've dissolved it, okay? They can be gases, liquids, or solids, but in general, for what you're going to see when we talk about a solution, we talk about something, you've taken something, you've put it into water, you've mixed it up, and you've dissolved it in the water. Okay, the main way that we're going to talk about the concentration of a solution is we're going to use it in terms of molarity. Okay, and molarity really is the only one that we need to focus on. And there's lots of other cases of concentration of solutions. For example, you can talk about parts per million. That's a measure of concentration. How many parts are there per every million particles? That's a very common form of expressing concentration. There's one called molarity, which is another way. Again, there's lots and lots of different ways, but in terms of for the AP classroom, we are going to talk simply about molarity, okay? And molarity is measured, we do use a capital M here, so be real careful that we don't confuse that. And that's why here on our equation sheet, when they discuss molarity, they write it like this. They write it just like how it's written there. Because, again, that big M is the same big M for molar mass, when remember that molar mass equals dRT over P equation. Those two M's are not the same, even though they are the same letter. Okay, that's the molar mass of a gas. That's molarity. Okay, molar mass of a gas, not too commonly found. Molarity, huge on the AP tests. Okay, so molarity is measured in the moles by the moles of the solute per the liter of the solution. So another way of writing it is M equals moles over liters. Okay, so again, the big M here stands for molarity, and that is the moles of the solute. The solute is the stuff that you're dumping into the water. Okay, so if you're taking some salt and you're putting salt into water and you're dissolving it and you're measuring the concentration, it's the moles of the salt divided by the volume, in this case liters, the volume of the solution. So that's not the volume of the water. Be very careful about that, okay? It says the liters of the solution, which is the volume after you've added the salt to it. We're like, well, that's not going to change very much. I understand that. I agree. But it is not the volume of the water. It is the volume of the water and the salt put together. Okay? So molarity is moles over liters. Moles of the stuff that you're putting into the water and liters of the entire solution after you've added the solute. Okay? The water in this case is called the solvent. So you've got the solute, which if we're talking about salt water, the solute would be the salt. The solvent is the water. And then the two of them put together, the salt and the water together, make up the solution. So again, moles of solute per liter of solution. Now, what if they give you grams of salt? Well, then, of course, what do you have to do? You have to convert those grams to moles. Okay, and we'll see that here in just a minute. Okay, so when we do molarity in calculations, okay, when you're given the grams of a substance, you can convert grams to moles or moles back to grams. The key for using molarity is obviously to know, you have to know the number of moles. So when you're working with a solution, a similar method can be used. Since molarity is equal to the moles of the solute divided by the volume, if we know the molarity and we know the volume, we can find moles. So we've learned that you can take grams and you can convert to moles, and you do that using the molar mass. But what I'm saying right here in this paragraph is you can also go 2 moles from the molarity. Okay? And how do you do that? Well, again, let's think about it. Molarity equals moles over liters. How do you solve for moles? How do you get moles by itself? You multiply both sides by liters. So molarity times liters equals moles. So now we don't just have one way to get from grams to moles. We also can use molarity. Okay, and if you think about it, there's actually three ways we can do it. Another way that we've gone to moles is using PV equals nRT, using the ideal gas law, right? Because we're trying to find moles, N equals what? PV, that's a P, over RT. Okay, so the pressure times the volume. So we've actually got three different ways we can find moles now. If they give us the grams, use the molar mass. If they give us the molarity, multiply the molarity times the volume. Or if it's a gas and we know the pressure, the volume, and the temperature, we just take PV over RT. So there's many, many different ways to get to moles. Okay, so let's look at some example problems. Example number 1, what mass of HCl is required to create 20 milliliters of a 0.809 molar hydrochloric acid solution here? So we're looking for the mass of HCl. So I always start with molarity equals moles over liters. And what do they give us? They give us the molarity. So 0.809. Now notice they write it as big M. You can write it as that. You can write it as 0.809 moles over liters. Or if you want to try to get really fancy, sometimes they write it as moles and then liters to the -1, which is the same thing as moles over liters. I don't really care how you do it. Okay, so that's our molarity. The moles we don't know. The volume, which must be in liters, is 20 milliliters. So quickly move that decimal point 3 spaces to the left to make it liters. And now I simply, to get moles by itself, I have to multiply both sides by 0.020. So 0.809 times 0.02 equals 0.01618 moles. Not worried about significant figures yet because I'm not done. Okay, so that's moles of HCl. And now I go to the periodic table. I look up the mass of chlorine, which is 35.45. I look up hydrogen, which is 1. So that's 36.45 roughly. And again, that doesn't have to be perfect. If you did 36.5, that would be fine as well. And I have that backwards. As soon as, I put grams on the bottom. And as soon as I did, I caught that because I thought, oh, wait a minute, moles have to cancel. So it's 36.45 grams on the top, 1 mole on the bottom. So I'm just using the number that's on my calculator screen. I'm going to multiply by 36.45, and I get 0.5897, which is going to round to 0.590. Both of these have 3 significant figures, so does my answer. So 0.590 grams of HCl. Okay, example 2. What volume in milliliters of ammonium nitrate is needed to create a 1.35 molar solution containing 42 grams? So the first thing we see right away is we've got grams of ammonium nitrate. We can't use grams, we have to use moles. So I'm going to take my grams of ammonium nitrate and I'm going to convert them to moles. So I need the molar mass of ammonium nitrate. So we've got 14 plus 4 is 18, 18 plus 14 is 32, 32 plus 48 is 80. So there's 80 grams in 1 mole of NH4NO3. And that's going to give me the moles. So 42.0 divided by 80 equals, again, no worry about significant figures here because it's not my final answer, 0.525 moles. And now they're asking for volume. So again, molarity equals moles over liters, and they're asking us to find liters. Okay, and this is a quick, easy thing that you can do. Anytime they ask you to find the denominator in a problem, okay, don't think too hard about the math here. Yeah, you can multiply both sides by liters and then divide by molarity. The easiest thing to do here, anytime they ask you to find the denominator, you just switch it with whatever's on the other side. So if molarity equals moles over liters, then liters equals moles over molarity. See how I just switched those two? And if you go through the algebra in your head, hopefully you'll understand that. I multiply both sides by liters, and then I have to divide both sides by molarity. And really what happens is, again, these two here just ended up switching places. Okay? So I need the volume. I've got the moles now. 0.525 moles. The molarity is 1.35. Again, big M, moles per liter, however you want to write it, they don't care. So 0.525 divided by 1.35 equals 0.389. And that is in liters. So my volume is equal to 0.389 liters. They want it in milliliters, which means I have to move that decimal point 3 spaces to the right. So that equals 389 milliliters as your final answer. Okay, and then example 3, this will be our last one for today. A student prepares a solution by dissolving 60 grams of glucose in enough water to make 250 milliliters of solution. The molarity of the solution should be reported as, so first of all, we've got grams, and they give us the molar mass. So let's take our 60.00 grams, and we're going to divide by 180.2 grams per mole. And again, I'm going to write down a number, but I'm really going to use the number on my calculator screen. Okay, it says 0.332963374. So I'm just going to write down a couple of those. 0.33, let's just say 30. Okay, even though I rounded that, I'm not even going to use that number. I'm going to use the number on my calculator screen. Okay, because now what I'm going to do is I'm going to take that number, and to get the concentration, the molarity, I have to divide by the volume. So I'm going to divide by 0.250. Notice I just quickly move that decimal point 3 spaces to the left to get to liters. So I'm not going to type in 0.3330. I'm going to use the number that's on my screen, and I'm just going to hit the divide button, and I'm going to hit divided by 0.250, and that equals 1.331853, blah, 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 blah. Okay, and then I look at the numbers that I used here. Again, I got lazy. This does have 4 significant figures. We have 4 significant figures here, 4 significant figures here. So my answer needs to have 4 significant figures. So I go 1, 2, 3, 4. The next number after my 4th number is greater than 5, which means that 1 has to round up to a 2. So it's 1.332. C is the correct response. Okay, and that's your introduction to molarity. Tomorrow we're going to talk about dilutions, and then we're going to talk about how to create a solution. But those are a good introduction on some basic problems dealing with molarity there.